Hello, this is Mrs. Brown, and today we're talking about geometric sequences as exponential functions. So first off, what is a geometric sequence? Well, the first term is not zero, and every term after is found by multiplying the previous term by a non-zero constant, r, called the common ratio. Okay, and so the common ratio is, to find it, you're just going to divide any term by the previous term in order to find the common ratio. So in this example of this sequence, 2, 56, 64, 4, and 1, I would do 1 over 4 is 1/4, 4 over 64 simplifies to 1/4, and 64 over 556 simplifies to 1/4. So in other words, the common ratio is 1/4 because if I multiply this number by 1/4, I get this number. If I multiply this number by 1/4, I get this number. If I multiply this by 1/4, I get this number. So it's that constant common ratio that we're going to be using in a geometric sequence. It's also what helps us identify a sequence as a geometric ratio, because if they have a consistent ratio of numbers between the terms, then it's going to be a geometric sequence. Okay, so let's look at some examples. Okay, again, you can pause this and write this down if you need to. Okay. So if I were to take 625, 125, 25, and 5, and I asked you if it was geometric, arithmetic, or neither. Okay. You would start by looking to see, is there a common ratio? Is it the same ratio each time? So if I do 5 over 25, that simplifies to 1/5. If I do 25 over 125, that also simplifies to 1/5. And 125 over 625 also simplifies to 1/5. So therefore, it is a geometric sequence. And the reason it's a geometric sequence is because we have this common ratio between all the terms. It's the same fraction each time that we're multiplying by. And it could be a whole number. It could be like 2. So if it was increasing instead, and I had this in the opposite direction, for instance, if I took the same thing, but I'm going in the opposite direction, well, this time I'd be doing 625 divided by 125, so it would be a whole number. It'd just be 5. And so the constant ratio would be 5, which is 5 over 1, which is how it's a ratio. But we just write 5. And the same thing, 125 over 25 is 5, and 25 over 5 is 5. So the constant ratio in this case would be 5, which we, again, could think of as 5 over 1. So let's look at another example. Okay. So if we take 5, 7, 10, or 15. Okay, so we start looking 15 over 10. Okay, well, 5 goes into both of those, so that simplifies to 3/2. But 10 over 7 is not equivalent to 3/2. I mean, I could find a common denominator of 14, but I can already tell you if they were equivalent, I would be able to simplify to 3/2. So these are not the same. So it's not geometric because it doesn't have that common ratio. So then I'm going to check to see if it's arithmetic. If it's arithmetic, the difference is the same for each one. So if I do 15 minus 10, that's 5. But 10 minus 7 is not 5, it's 3, so it's also not arithmetic. It's neither. Now, what would an arithmetic sequence look like? Well, let's say I had 3, 7, 11, 15. 15 minus 11 is 4. 11 minus 7 is 4. And 7 minus 3 is 4. So this one would be arithmetic, because the difference is the same each time. The ratio wouldn't be the same if I did it it wouldn't be geometric, it'd be arithmetic. And this one is neither, because neither the difference is consistent nor the division, the ratio is consistent. Okay, and so that's the first skill today, is just determining whether it's geometric, arithmetic, or neither. If it's geometric, then it's going to have the common ratio. If it's arithmetic, the difference between the terms is going to be the same. And if neither of those things are true, it's neither. Okay? All right. So then if we look at, what if I ask you to find more terms? So, for instance, if the directions say, find the next 3 terms. So, the first step you're going to do is find the common ratio. Okay, and then you're going to multiply the last number in the term by that ratio to figure out the next number. So let's say I had the sequence 2, 6, 18, 54. I'm going to find my common ratio. 6 divided by 2 is 3. 18 divided by 6 is also 3, so that's my common ratio. And so I take 54 times 3 gives me 162. 162 times 3 gives me 486. And 486 times 3 is 1,458. So the next 3 terms in this sequence are going to be 162, 486, and 1458. So again, finding the common ratio, you multiply the last one by the common ratio, and then that answer by the common ratio, and that answer by the common ratio, and you can continue the sequence. Okay, so let's look at an example of that. Okay, so if we look at the sequence, 1, -3, 9, -27. Okay, so start by finding the common ratio. So that would be -27 divided by 9, which is -3. If I check, 9 divided by -3 is also -3, and -3 divided by 1 is also -3. So my common ratio, R, is going to be -3. Okay, then to find the next term, I would do -27 times -3, which is going to give me positive 81. And then I would do positive 81 times -3, which would give me negative 243. And then I would do negative 243 times -3 and figure out that the final term here that I'm looking for is 729. So the next 3 terms are 81, negative 243, and positive 729. So again, once you find that constant ratio, you're just using it, take the last term, multiply it by it, and then each time you get an answer, you multiply by it so you can find the next 3 terms. Okay? And well, let's take a look at one more example, because sometimes, of course, these can be fractions. Fractions are your friends, remember. They're a good thing. Okay. If I look at this ratio, it's 128 divided by 256, which simplifies to 1/2. I can check that. 512 divided by 1024 is also going to be a half. So to figure out the next term, I do half of 128, which is 64. And then I'm going to take half of 64, which is 32. And then I'm going to take half of 32, which is 16. Okay, and so again, the next 3 terms would be 64, 32, and 16, because I'm multiplying by that constant, that common ratio. Okay. All right, so that's all well and good. Like if I want like the next 3 terms, but let's say I want to know what the 100th term is. It would take a really long time to get there. So we want a shortcut, right? We like shortcuts. So here is the formula for the nth term. And the nth term could be whatever one we're looking for. So if I want the 100th term, I could find it. Or if I wanted the 50th term and not having to do every single thing out. Okay, so finding the nth term of a geometric sequence, we're going to represent it by a sub n. That would be the nth term. And the first term is a sub 1. So that n represents the number of the term. So a sub 2, a sub 3, a sub 4, all the way up to whatever it is. So if I want the 100th term, I would write a sub 100. So it's whatever one I'm looking for. And common ratio R, which we already know what the common ratio is given by the following formula, where n is any positive integer. You have the first term, and R is not 0. So the nth term equals the first term times the common ratio to the n minus 1 power. And we'll look at some examples of that. Again, you can pause this. I really highly encourage you to write it down so that you have this formula. It makes it a lot easier. Okay. All right. So if we take a look at An example, okay, I have -3, 12, -48, and 192, okay? If I'm looking at how this changes each time, again, my common ratio, 12 divided by -3 is -4. If I double check with -48 divided by 12, also -4. So that's R, okay? This is my first term, so it's A sub 1. And so if I'm looking at my formula, the nth term is going to be A sub 1 times R to the n minus 1. So it's going to be -3 times, and R is going to be -4 to the n minus 1. So then let's say I want to figure out what the 10th term is. So I substitute in 10. So 10 minus 1 is going to be the 9th. If I do -4 to the 9th power, it's a really big number, -262, 144. Again, this is where your calculator is really useful. And so the 10th term, and I should have put a 10 right here, the 10th term, we multiply that together, is going to be 786,432. Okay, and so again, using the formula, substituting in the stuff once you find it, and then you can just calculate whatever number you want. Again, if I wanted the 100th, I just put 100 here instead of 10. Okay, I hope this makes sense, and have a fabulous day.